we are going to declare this as IR receive. This is your class. Then the instant of class, it is the user defined one. You can give any value. Okay, any name you can declare. This is user defined name. Then followed by the pin. Which pin we are going to use it as a receiver pin? That pin number you need to mention. Okay, these are all the two things. Then what about the third one? Very simple. Whenever I start receive the signal, I need to enable my receiver. How to enable that? Simply use this function. See, hereafter we are going to use same instant. This IR receive I'm going to use. So IR receive dot this enable IR IN is an inbuilt function. Okay, you can't vary this one. It is case sensitive. You need to follow the same format. This is to enable your IR receiver, not your transmitter. Whatever the program we are going to write, it is only for the receiver, because your remote is already manufactured. Already it has a microcontroller. So user can't do anything. User simply they can activate the buttons. Only receiver part you can do your programming portion. Okay. So the third one is how to enable. What about the third one? Third one, I'm going to use one more variable to store the results. So this is user defined function. You can variable, you can give any name here, but this is default decode underscore results. Then after that IR receive blink. See, this blink is the inbuilt function. Once you make this to true, true means what will happen? Whenever my IR receiver receives the signal, my LED, 13th LED, that onboard LED will blink. What for they gave? This is why, since it is a wireless device, you can't recognize whether my information is transmitted or not. You can't check the output with the help of multimeter and all. Since it is a wireless communication, you need some indicating device whether I have received the signal or not. For that purpose, what they may, whenever my signal is received, this LED will blink once. Today we will observe the same thing while we do the simulation. Okay, so this is for testing purpose. At the same time, if you enable this action, you can't use the 13th pin for any other application while it receives, because while it receives, it will make the device to on and off. If you are using the same pin for any IO control, whenever you receive, it will disturb your output. That may lead some accident. For that, if you use this option, please ignore the 13th pin. You should not use the 13th pin for any IO devices. So what are all things we have seen? Header file, first one, then instant class and object, then how to enable is the third one, then one more variable to decode the result. The last one is how to enable the 13th LED to blink. Then after that, few more things. So as we discussed earlier, what I need to do, whenever I receive the command, I need to decode the command. Ram sir, hello.
சொல்லுங்க அஜிதன் சார்.
ஒரே நிமிஷம்
சொல்லுங்க.
இல்ல விசிபிளா தானே இருக்கு?
விசிபிள் தான். கேக்குதா?
எஸ் எஸ் கேக்குது சார். 1 minute இது ஹேங் ஆயிருக்கு. ஒரே நிமிஷம். Yes. So header file, everything is over. Then we are going to see few more syntax. Then immediately we will come to our today's exercise. Please wait for a minute.
Yes sir, visible.
Visible sir, but ஒரே நிமிஷம் சார். PPT மட்டும் லைட்டா ஷூர் வெயிட். Let me close and open. Wait a minute. Yes, close the program. Yes. Yes, where we left up to the header file and few syntax. Now we will continue the remaining things. Important one, please make note of this one. How to decode. Once you receive the information, is it visible now? Shall I continue, sir?
Visible, sir.
Yes, sir. Yes. Once you receive the information, you need to decode it. So how to decode? This is the inbuilt function irReceive.decode. Then within the argument, we are going to pass the two things. One is the ampersand at results. So this function, what it will do, it will check for the received information. Once the information is received, it will give true. If it not, it will pass the value as false. So by checking this, I can check the condition whether I have received the valid information or not. At the same time, it will store the value into the variable name called results. Okay, it will do two function. One, it will check. The second one, it will store the information into results. Then after that, what I need to do? I need to view the value. Means you simply you print the value and view the value. Then according to the value what you required, we can start write our program logic. Before that, once you want to restart the second time, you want to receive the same thing, you need to resume. What it means, after receiving the for one information, you need to reset the receiver. Then only it will prepare to receive the new information. Okay, don't forget this function. If you forget this, it won't receive the new information. It will hold only the previous one, that is old one. Okay, that's all. So only with this help of the coding, we are going to start write the program. So the first task, what we are going to do, we are going to make your LED to on and off. How to control? We are going to use the remote control power on button. So this is the flow of the your exact program. So the first one, we need to include the header file. Second one, what I need to do, what I'm going to declare the receiver pin number. So the receiver pin number here, it is pin number 7. I am going to use it. That means the receiver pin, I am going to connect it in the Arduino IO pin number 7. Then I'm going to create the class and instant of the class. Then immediately I'm going to declare the pin number variable. After that, I'm going to declare one more variable. Then this toggle function, you know why we are using toggle function. Once you check the loop program, you will come to know why we have declared this toggle. Then void setup. In void setup, what I have to do? In void setup, I need to first configure the LED output pin. LED output pin, LED I have connected in pin number 9. So as usual, I will make the pin number 9 as the output pin. Then by default, the LED will be in off state, followed by I need to enable my IR receiver. After that, I am going to enable that blinking action. So these things must be in the setup. That last line is only one is the optional. Remaining things are mandatory. Okay. Then void loop, what I'm going to do? Simply we are going to decode the value. Then if it is decoded, it passes the value as a true. Then I will come down. Then I will check the button value. Say example, this power button, once you press the power button, it will send some waveform. That waveform, once you decode it, you will get this value. This value includes your address and data. Please make note of it. This information carries address plus your data. Then once it matches with the required button value, I can start do the logic. What is the logic I am going to do? I am going to first time I am going to pass the toggle value as the default value. So first time I'm going to pass the same default value. Then immediately I am going to toggle. That is nothing but I am going to do the not action. Logical not. That means 1 means 0. 0 means 1. What is the relation between this 1 and 0 and the LED on off condition? As per our program, if I make the logic 1, LED will turn on. If I make the logic to 0, LED will get turn off. That's all. So after that, I need to resume. Why I am going to resume? I am going to restart my receiver to receive the new command. That's all. With the help of these commands, we are going to start do the exercise once again. Okay. Do you have any doubts so far? Please type it in chat box. Else we will go to the simulation portion. Sir, is it visible, sir? Shall I continue? Ram sir? Moon sir? Hello? Hello? Sivakumar, is it visible? Can anyone type it in chat box? Let me
Sir,
continue.
visible, sir, visible.
Yes, sir. Okay.
Hmm.
Now, um, for that, for this exercise, what are all the components I need? Simply one resistor, then LED, resistor and
Yes, sir.
okay, sir. Resistor, LED, then IR remote. That's all. Hardware connections are very simple. Okay. Let under receiver. Where is IR receiver? IR receiver will available in the input device. Where is IR receiver? This is my IR sensor. So how many pins are there? As we discussed earlier, we have a 3 pins. One is out pin, second one is ground, the third one is power pin. Let me do the wiring step by step. The first one, I am going to connect the VCC pin. That is 5 volt, logical 5 volt. We are going to connect it. Logical 5 volt. That's all. Then ground pin. Pin and ground. Then we are going to connect this output pin. So as per our program, we decided the digital input pin as a pin number 7. Let me use the same pin number. It is not mandatory. I need to use the 7th pin. You can use any one digital input output pin. Okay. That's all. So out pin, ground and VCC, the wiring over. Then for LED connection, let me connect the LED. So we have used pin number 9 as a output pin. So one end of the LED I have connected to the resistor. Let me change the resistor value as a 220 ohm. Resistor value as 220 ohm. Then cathode terminal, I am going to connect it into straight away ground. See here also you have one more ground terminal. So there are 3 ground terminals available in this board. So this is one ground, this is another one, this is the third one. So all the ground pins are common. Okay, that's all. So we have connected LED in the output pin number 9. Then IR sensor I have connected in pin number 7. Now come to the code part. Go to text. So here, since we are going to use a new device, this device, I need some header file support. So what I'm going to do, I'm going to click this icon, second icon called library icon. Please see here. Yes. Yes, this library icon I'm going to click. I'm going to include IR remote. Okay, I'm going to include IR remote. The point number 1, we have included the header file. Then after that, what I need to do? I need to declare any one receiver pin. So let me include the receive pin variable. Receive pin as a pin number 7. Okay. Then after that, what I need to do? I need to start declare few things. It is a mandatory things. So first I am going to declare the object. Object name is the fixed one. The instant of the object you can change it. Okay. that is user defined value. So IR receive is the object name. The instant of the object, what I'm going to keep, let me keep it as a KCE IR receive. KCE IR receive. That's all. Then followed by the pin number. Followed by the pin number. So pin number already we have declared one variable name. Let me use the same variable name. After that, uh, I need to declare one more variable that is called double decode decode underscore results. Decode underscore results. See, this is also a inbuilt function name. You can't change this one. You need to use the same syntax. All letters are small letters. Okay, then followed by the variable name, that is user choice. So user choice, let me type it as a KCE results. KCE results. That's all. Then I'm going to declare one more global declaration value as boolean value. Bool toggle. Toggle is the variable name. By default, let me keep the default value as the 1. Okay, then come down in void setup. Please observe, this is your header file. This is your header file. Then this is your class and instant of class. Then this is the another variable. Then one global variable. So if you want to use the particular variable in both setup and loop, means you must declare it in global declaration. Then now you come back to the void setup. In void setup, what we are going to do? Simply, we are going to configure the pin number 9 as a output pin. Why 9 as output? Can anyone tell? Why 9 as output? Because see, if you observe your hardware circuit, the 9th pin is configured as an output pin. So, see, 9th pin I have connected LED. Therefore, I need to configure the pin as a output pin. Then followed by, I'm going to make the pin as a, by default, I'm going to make the pin to logic low, 9, 0. Okay, so these two is related to my LED output indication. What about the IR sensor initialization portion? In that, I need to do two things. One is I need to enable my IR sensor. So how to enable? Let me use the instant of class. Same instant of class, I need to use it. So KCE IR receive dot enable enable IR IN. That's all. N must be small letter. This is the inbuilt function. Followed by I need to declare one more function. So that is my LED blinking of the 13th pin. So whenever I receive the IR signal, my 13th LED will blink once. So let me, this is a what logic I am going to pass it here? True. True means it will get enabled. False means it won't work. Okay, that's all. So in void setup, only two things are very new to you. One is how to enable your IR receiver. Then the third one is the blinking an LED. Then in void loop, what is the actual program we need? What we need to check whether I have pressed this power on button or not. See, power on button. This is our power on button. Once I press the power on button, my LED has to turn on. Very next time, if I press the same power on button, LED has to off. It is very simple. Even in your set-top box, what you are having one power on LED, whenever you press your remote power on button in your set-top box remote, once you press that, the LED in the set-top box will get turned on. Second time if you press, it will get turn off. Okay, the turn on and turn off function, with the help of this power control button, we are going to do it. For that, what I need to do, let me erase the old things. Let me type the new program what we need. So very first one, I need to decode the value. Okay, so how to decode? So I have a special function called decode. Why I need to decode? Whatever the information received by the IR sensor is not the actual information. I need to decode it. Then only I will get the actual data. So the data consists of address and command. We will check one by one. So let me decode it. So this is the actual syntax. So here you have declared one more variable. In this variable only, we are going to store the received value. That is called KCE results. So if I run this function, it will give the logical value as a true or false. Once I check the true or false, if it is true, I need to do the second action. Before that, what we are going to do means, see, before that, let me check what are all the values available for the individual buttons one by one. Let me show that one. See, simply we will print this variable and we will check how we arrived this value. Okay, how we arrived this value. Now we will check it. Come back here. Come back here. And what I am going to do, I am going to initialize the serial monitor. Serial dot begin. Serial dot begin 9600. Okay. Then what I'm going to do, simply I'm going to print the variable name. Once it is received, what I'm going to do, I'm not going to make my LED to turn on. Simply I'm going to print the value first. Let me show that value first. So KCE receive dot value. Sorry, results, KCE results dot value. KCE results dot value. See, actually, once you read the thing, the value will get stored in this KCE results function. In that, if you take the value alone, it will give the value. That's all. Now I am going to print. After that, what I'm going to do, I'm going to resume. I'm going to restart the receiver once. So KCE IR receive dot resume. That's all. That's all. Please observe. Please observe. See, now we are not going to make our LED to turn on. Simply we are going to check the button. Once button is pressed, what is the value we are going to receive in the serial monitor? We are going to check it first. Then we will give the value to work. Okay. Now I am going to start simulate this one. Okay. Yes. Now let me maximize the serial monitor. Now I am pressing the power on button. Value not printed. Wait. If it receives, print the value serial dot value, serial dot begin. Wait a minute. Then immediately resume the action. KCE receive resume. If it's resume. Okay. Do one thing. All the time it gets resumes. So therefore, not allow our system to receive the signal. Let me put it in the loop and check. Only in this condition, once I receive, then only I will restart. If I put it in outside the loop, see, very good. See, what mistake we did means we made the reset action outside this whole loop. So all the time, whenever it enters a while loop, immediately it resets. So it is not giving the time to process. That's why in the loop condition, whenever it receives, I am process it. Then I will reset and come back from the particular loop. Now you check the value. So whenever I press the power on button, see power on button, I am getting this value. Okay. So this is the equivalent decimal value of the power on button. This information consists of, please observe this waveform. This information consists of address as well as the command. Address as well as the command. It is simply, if you type the information, it will give it in the decimal format. If you want to see the information in binary values, let me see what I have to do means, whenever you start print the information, the particular variable name, comma, simply I am including the term called binary. See, binary. If I give this particular binary information means, start simulate this, start simulate this, start simulate this. Now you press your power on button. See, this is the equivalent binary information of your key. See, if I press some other button, see, now I pressed only power on button. If I press some other button, it gives the different pattern. Please observe the change. Please observe the change in value. So likewise, each and every button have some pattern. This pattern you need to note down, then you need to access that one. Okay. So for that, what I'm going to do means, for my exercise, I am going to use only the power on button. So the equivalent decimal value of the power on button is how much? How much? This one. So let me take the same value, copy this value, minimize your serial monitor window. Then minimize the serial monitor window. Now use that value to check the condition. Okay. If my KCE results value, I hope it is understand for everyone how to check the value. So each and every button have a individual pattern. But first time you need to check. Else, if you have a data sheet, by referring the data sheet, you can use those values. Okay. So now first time I'm going to use the decimal value. After that, I will show you how to use some binary value or hex value that we will see in the second exercise. So far we have seen how to print by default it will print only the decimal value. If you give the print statement with another name called binary as a variable, it will convert your value into binary and it will start print. So now what I'm going to do, I'm going to check the power on button condition. If it is true, what I need to do, I need to make my ninth pin to work. So ninth pin, what I'm going to do, simply initial value I'm going to pass. The initial value is toggle. Let me pass the value as toggle. Okay. After that, immediately I am going to include the second condition. So because next time if I press the same button, I need to do the reverse action. For that, I am going to do the logical not function. That's all. Okay. So please observe the program. We are going to decode the value. Once you decode it, you are going to compare the value. Once you compare, you are going to pass the value into the particular pin. Then immediately what you are going to do? You are going to toggle the value. 1 means 0. 0 means 1. Okay. Let me check the output now. Now you start simulate your program. Start simulate. Yes, let me add one more thing. One more brace is missing. Yes. Let me minimize the code window. Now observe this output alone. Initially, my LED is in off condition. If I press the on button once, power on button, LED will get turned on. Please see here, LED is turned on. If I want to make the LED to off, what I have to do? I need to press the same button once again. That's all. Okay. Okay. Is it clear for everyone? See, now I'm going to press one more time. Okay. So likewise, you can achieve the wireless control. There is no hardware connection or wire connection between the transmitter and receiver. Transmitter is in one end, the receiver is in another end. Okay. So this, using this wireless medium, we are going to control the device. What about our the
Onboarding.
second? Sir? Onboard LED. Yes, yes.
Onboarding.
Yes, sir, yes, sir. See, whenever I press the remote, please observe the onboard LED. Please observe, this is our onboard LED. See, if I press the power on button, see, so I need to start simulate the function. Now you check. See, initially it is in off condition. If I press the button, please observe, it blinks once. That's all. It won't turn on continuously. It will give only the blink indication. Then the corresponding output will, you can view the corresponding output. It is not only for this power on button. If I press any one button, see, let me press button 0. At the time also what it will give the indication, but logical change won't happen because we wrote the program for only power on button. See, if I press any other button, it will receive, but it won't disturb my output. Okay. Do you have any doubts so far? Please type it in chat box. It is a very new component. That's only for the purpose only we are taking second time. If you understand only, we can continue our second task. Second task, you are going to guide me how to write the program. Second task. What is our second task? I am not going to show the, sorry. Yes. See, this is our second task. So in this, we are going to use, sir, shall I continue, sir? Ram, sir?
Yes, sir.
Ram,
It
sir?
is visible.
Okay,
Yes,
sir.
sir.
Okay, see, in this case, please read the statement. LED on and off control, using two buttons in the IR remote. You can use any one button, any two buttons to actuate it. But here in our example, we are going to use the same logical value button. See, 0 means turn off the LED. 1 means turn on the LED. So here the one button has the control to only on the LED, not to off. In the same way, this off button capable of only to make your LED to off. Okay, so on and off action with the help of individual buttons. Let me see the video first. Accordingly, I need to write the program. Please observe the, wait. Please observe the animation once. See, initial, if I press the button 1, LED gets turned on. Okay. If I press off button, it has to turn off. If I press on button, LED has to turn on. If I press 0, LED has to turn off. Okay. So how we are going to do this? See, the same program, we are going to do few modifications. Come back here. So no change in the hardware connection, only the code portion we need to change. Let me come to the code. Before that, what we will do, we will check the equivalent values first. Okay. Let me comment these lines for a moment of time. Okay. So first what we are going to do, we are going to check this particular value for two buttons. One is for 0, the second one is for 1. How to check this? See, if I simply type the value as this, it will give the equivalent decimal value. Please make note of it. If I add some conversion, it will convert it. You have a number of the different number systems in digital electronics. You are going to study those things. Let me show one or two things here for this exercise alone. Okay, so let me minimize this serial monitor window, clear it, and start simulate this. Okay, we will let me include
Brace on
this.
it, sir.
Sir, இதோட போட்டுடலாம் சார். Okay, start simulate. See, what you can do, you can check all the buttons once, and you can make one tabular column, and you can use those values. How to use this, I will show you now. Okay, see, now I am going to check the 0 button. Let me press the 0 button once. See, oh, since it is in a continuous loop, it starts printing the value. Okay, let me stop and take down the value. So this is for 0th button. Okay, this is for 0 button. Let me take it. So 0 button equal to this value. Okay, then for next one, let me start simulate once again and press button number 1. So this is the another value. So this is equivalent to our button number 1. So this is the value equal to my button number 1. These are all the decimal values. These are all decimal values. See, why it keeps on printing the value means we are not reset that one. If you reset it, it will erase the previous one. It will wait for the new command to receive. Okay, now, so these are all the decimal values. According to these decimal values, we are going to control our output function. Okay, how I can control? Let me start write the program. What are all things I need to do here? So the same receiver pin, I'm going to use it. That is point number 1. After that, so here we are going to use same single LED as output. So in setup, in a global declaration, no change. In void setup also no change. Only in the loop statement, I need to do two conditions. What are all the two conditions? The point number 1. The point number 1, if I press the button number 1, let me take the button number 1, equivalent decimal value of my first button. We take the value, simply replace it with the equivalent value. Okay. See, if I press button number 1, what I have to do? I have need to make the LED to turn on. Simply pass the value as 1. That's all. If button number 1 is pressed, if my number 1, okay, number 1 means what I need to make the LED to on. I need to make the LED to on. LED to on. That's all. Else if what I need to do? Else if the second condition. This is equivalent decimal value of my button number 0.
Sir, brace
Number. என்ன ராம் சார்?
if statement brace close பண்ணல மேல.
பண்ணிடலாம் சார். சார் இங்கே க்ளோஸ் பண்ணியிருக்கல ராம் சார்.
இல்லை எல்ஸ் இஃப்
ராம் சார்
போட்டிருக்கீங்களா, அதுக்கு முன்னாடி க்ளோஸ் பண்ணல அங்கே போட்டிருக்கீங்களா? ஓகே ஓகே
போட்டிருக்கு ராம் சார், போட்டிருக்கு சார். So,
ஓகே ஓகே
yes, sir.
ஓகே
If இங்க இப்போ button number 0 is pressed, I need to make my LED to off. That's all. That's all. Please go through the program once. In earlier case, the same thing, we used only one button, power on button alone we have used. Okay, so power on button alone we have used to control our LED. Now in this case we are going to use two individual buttons. Number 1 for turn on the LED, number 0 for turn off the LED. How we arrived this decimal value? Simply we have executed this particular command. With the help of the command we know the results value, then simply we mapped those values. Okay, so here this boolean variable is not required. Let me comment this line. That's all. Shall we check the program now? Yes. Before that, let me check the braces whether I have closed. This one extra. If yes. See, if you are in Arduino IDE, this braces and all, if you click any one braces, the open and close it will show. Okay, in this IDE, in this software, it is not showing those outputs. Let me minimize the code window and come to this animation. Now, initially, my LED is in off condition. If I press button number 1, see, I turned on the LED now. How to turn off the LED? If I press again the button number 1, it won't turn off. I have a separate button. So I need to press button number 0. Why it is not off? Come to the program and check. I think we may not change the logical value. See, here we forgot to change the logical value. See, our program flow and logical value, what you are checking. In the same fashion, if you check, you can debug the program. See, on condition is okay, means nothing wrong in the on condition statement. Only off statement I need to check. In off statement, what I have did, I made one mistake. Here I forgot to change the logical value. Okay, now I start simulate this one. Start simulate this. Yes. Now, if I press button number 1, my LED will get turned on. If I press button number 0, LED will get turned off. Okay, very simple. Any doubt with this? Any doubt with this? Do you have any doubt so far? Please type it in chat box, else we will continue. Okay, shall I continue? Yes. Let me do this same exercise in another way. In last class, someone asked, sir, is it possible to use the hexadecimal values? Okay. How to use the hexadecimal values? See, very simple. See, the number systems you will study, don't bother about the new term. So binary means 1 and 0. Hexa means we will group those binary values, then we will make some other code called hexa value. Like that you have a different coding values, octal and hexa. Okay, now I will show what is the equivalent hexa value for this button. Okay, let me check the same. See, KCE results dot value, comma, to convert the particular value into binary, what we have typed? BIN, binary. Okay, if I type BIN, it will give the equivalent binary value. If I type, I will do one thing. Let me type all the values one after another. First one is simply decimal value. First one is decimal value. The second one is the binary value. Binary value, what I have to do? BIN. Simply it will convert the particular value, the equivalent to this value. it will convert it into binary and it will start print the particular number. Then if I want to convert the same thing into hexa value, hex, that's all. You have a one more code. No need to bother about that. Simply octal is the another type of code available. Okay, let me start print this one by one after another. It will start print. See, if you want a clear indication of what you are going to print means, that also you can do. The first one, what you are going to print is the decimal value. Decimal value. Second one, what you are going to print is the binary value. Binary value. The third one is the hexa value. The last one, sorry. And the last one, octal value. Don't bother about these new terms. You may study these things little in your standard. Yes. Now let me take the different conversion values in the serial monitor. Start simulate this. Start simulate this one. Okay. Wait a minute. Println. Yes, okay. Now you observe this window. See, now I'm going to press the button number 0 once. Clear this one first. Now see. So this is your decimal value. This is your binary value. This is your hex value. This is your octal value. So these are all the converted values. So what is the advantage of this number system means? Let me show you that one. See, if you use this conversion function, see, this is your decimal value, this is your binary value, this is your hexa value. So if you use hexa value or any other coding system means, if you use any coding system means, the digits gets reduced. So I no need to type this much digits. If I use hex code, actually in our embedded system or microcontroller, we will use most of the time we will use this hex code. We are not use binary code. Actually, the binary code is exact of your machine code. So in this pattern only, your inside components is going to work. See, 1 0 1 0. Likewise, it is going to work. Let me show one more information here. As we discussed earlier, my particular device has few informations, isn't it? So it has a 8-bit data and command. See, first 8 1. See, 1 2 3 4 5 6 7 8. This is one command. Then another one, 1 2 3 4 5 6 7 8. This is the another one. See, if you compare these two, the inverted value you will get. Here it is 0 means here I will get 1. Here it is 0 means here it will get 1. Here it is 1 means here it is 0. So in this way, we are going to send the values in a command and not of the command value. The remaining things are your address of the particular device. Okay, so what is the application of this? How I can use it simply? See, hereafter, if you want to use any hexa values in the next exercise, what we are going to do means we are not going to use this decimal value. We are going to use the hexa value and we are going to compare the logical statement and we are going to make the output. Okay, so that's all regarding the number conversion. How to use it, we will see it in the These are all the equivalent hexa value of all the buttons. This data we will share to you. You can make use of these values. These are all individual buttons decimal value and equivalent hexadecimal values. If you use hexadecimal values, the number of digits what you are going to use it getting minimized. Okay, and also it is easy to remember. See, FD00F, it is very simple to remember, but this is it is having more number of digits. For that purpose, in the most of the controller we are going to use only the hexadecimal values. Now we will come back. Now we will come back to the last exercise. What is our last exercise? Yes, this one. This one. Please observe the animation. Here we are going to, sir, is it visible, sir? Shall I continue, Ram, sir?
Visible Gajendran, sir.
Yes, sir. See, here we are going to use the two device. One is LED, another one is the buzzer. We are going to control this LED and buzzer with some other control sophistication. How we are going to control it means, please observe here. Here I am going to use the power on button as the master key. Please observe. Here I am going to use the three button. One is the power on button, then LED on off control using button number 1. Buzzer on off control using button number 4. Please observe, I'm going to use only 2 appliances to control, but I'm going to use the 3 buttons. What is the mean? Why I'm going to use 3 means this power on button is the master control. Whenever I turned on this power on button, then only my system will start recognize these inputs. Okay, even if you compare with your TV remote box, TV remote or set-top box remote, whenever you turn on the power on button, then only you can change the channel or you can increase the volume. Then whatever the channel is present in the TV, immediately if you press the off button, what happens? Immediately your TV will get turned off. In the same analogy, we are going to do this control. We are going to control 2 appliances. For that, point number 1, we are going to use one master control, followed by individual buttons. Individual button, here in our case, the button number 1 is for LED on off control. Button number 4 is for buzzer on off control. Along with that, we have included one more LED. This is not an actual output device. It is going to give the power on indication alone. Power on indication. Once you made the remote to press with the help of power on button, once you made the power on button to press, immediately this power on LED will get turned on. This is not your output appliance. Your appliance is here. One is this red color LED, another one is the buzzer. Now you see the animation once, then we will start write the code for this. Please observe this. Is it visible, sir?
Visible
Yes, sir,
Gajendran.
it is visible.
Okay, sir. Yes, sir. Please observe the video animation once. See, now I made the, now I am going to press the power on button. Please observe power on button. Immediately the power on LED will turn on. Okay, but no output, no output. Now I am going to make the LED to on. Press button number 1. So LED turned on. Again, if I press the same button, LED will get turn off. Similarly for buzzer, please observe. See, now both the things are on. Okay, now both the things are on. At that condition, I'm going to switch off the master key. See, both are turned off. Okay, so likewise, we are going to do the exercise, but I'm not going to show the actual code. You need to give the hint how to write the code. Okay, so let me repeat once again. This is the master key. These are all individual appliances key. Okay, come back. Now we will go to the simulation. I will go to the simulation. Let me do the hardware connection first. What are all the components, new components we need to add? We will add those components. So LED is already present. Okay, only buzzer I need to include. Take the buzzer. Take the buzzer. Yes, piezoelectric buzzer. Yes. After that I need one power on LED that we can make it from this. Let me take the breadboard also. We have having more components. Let me take the breadboard. By the time you think how to write the coding, yes, that's all the component we have choose. Yes, let me power the breadboard first. Yes, we power the breadboard. That's all. This is the first sensor. Yes, so this is my power pin. Let me connect it in the VCC. Then the middle pin ground. That's all. Then output LED. This is our output LED. Then current limiting resistor. Current limiting resistor. Yes. So cathode terminal, straight away I'm going to connect it to the ground. Anode terminal, let me use any one digital input output pins. Let me use the pin number 2 here. Pin number 2. Pin number 2. And one more buzzer. Buzzer. Yes. Buzzer. Negative terminal straight away connected to the ground. Positive terminal. Let me use the pin number 3 as another output terminal. Yes. So what are all things we have finished? We have interfaced the sensor, LED and buzzer. Along with that, we are going to include one more power on LED. power on LED. So what for this power on LED? It is simply to give the indication that my power button is in on state. Sir, is it visible, sir?
Visible,
Hello,
Gajendra.
sir. Okay, sir.
Visible,
Okay,
sir.
sir. Okay, sir. This is our power on LED. So cathode terminal, let me connect it to the ground straight away here. Okay. Anode alone. Let me take it to the another digital output pin. Say example, we will keep it as a pin number 4. That's all. So this is our power on LED. So whenever I turned on this power on button, this LED has to turn on. Okay. Then after that, I need to read these two. If I press the button number 1, I need to make the LED to on and off. Let me label this pin for better understanding. Let me use this as LED on off. Okay. LED on and off. Both the function we are going to control with the help of this switch. Okay, first pin number 1. Then the second one is pin number 4. So the pin number 4 is for buzzer on and off. So for that, what I have to do, first I need to read the buttons, then I need to take the value of those buttons, then I need to pass those values. Okay. Yes. Okay, now the hardware connection is over. We will go step by step. First, what we will do, we will make the power on button to on and we will check this output. Then we will include LED. After that, we will include the buzzer. Before that, check connection once and make note of the pin numbers. So the buzzer is connected in pin number 3. Then power on LED is connected in pin number 4. Then LED is connected in pin number 2. LED pin number 2. Then buzzer pin number 3. The master LED, that is power on LED, is pin number 4. 2, 3, and 4. Now you come back here. The code portion. So the point number 1, what we are going to do means simply we are going to read the buttons. Come. Let me take all the things off. Only will check the decimal value. At last I will show the hex value. Okay. Now we will start print this one. If this is pressed, after that we are going to resume this, then outer loop. Okay, start simulate this. You will note down all the equivalent decimal values of the individual buttons. Clear this one. Yes, come back here. First we will check the power on button. Power on button. Press once. So this is the equivalent decimal value of my power on button. Make a note of this. Make note of this. Stop the simulation and make note of this. Power on equal to this value. Okay, power on. Then start the simulation. Check for button number 1 and 4. Okay, check for button number 1 and 4. Clear the monitor. Now you press button number 1. So this is the equivalent decimal value of button number 1. Then you press 4 also. Let me take both the values simultaneously. So this is the equivalent value of button number 1. This is the equivalent value of button number 4. Let me take these values. Let me take these values. Copy this one and paste it here. That's all. So this is for button number 1. 1 equal to this. So this is the value equivalent for the button number 4. That's all. Now let me keep these values as some reference value. Some reference value. So copy this line alone and take it as a reference here. Whenever we want, we will take the value from here. Okay. So first we need a power on button, and we will press the power on button and we will check this master key and LED is working or not. Then we will come to LED. Then we will come to buzzer. Yes. Come first. First, we will check the pin configurations. So because we made few modifications in the hardware circuit, so we will check the receiver number, pin number 7 is fixed one. So we didn't disturb that one. What about the other one? The other one is this. See, the fourth number is the master LED. So fourth number is the master LED. Let me give the variable name as power on LED. Power on LED. So power on LED is equal to pin number 4. Power on LED is equal to pin number 4. Then what is the second next one? LED and buzzer. So the next actual output LED is connected in pin number 2. Actual LED is connected in pin number 2, followed by your buzzer. Followed by your buzzer. Okay. So buzzer is connected in pin number 3. That's all. Okay. So initial declarations are over. Then, so here what we are going to do, we are going to use the single button for make your LED to that power on LED to on and off. Okay, isn't it? So for that, what we need to do, we need to make some variable. We need to declare in this initial condition. Then accordingly, we will make the things to work. Okay. So first one, what I am going to do, let me use the same Boolean toggle as my power on LED. Let me use it. This is for toggle power LED. Let me keep it as a power LED. Okay, power LED. Come down. What are all the pins we need to configure as an output? There are 3 pins. There are 3 pins. We need to make it as a output pin. One is the power on LED. Another one is the buzzer. See, these 3 I need to make it as a output device. So first, let me make it as a power on LED. Power on LED as the output. That's all. Then immediately make the pin to logic low. Finished. And what about the second one? Second one is my output LED, then my buzzer. Let me take the copy of these 2. The next one is my LED. Take the LED variable, make it as a output pin. Make it as a output pin. and logic value also 0. Okay, that's all. Then buzzer. Take the buzzer. Take the buzzer. Make it as output and initially default logic 0. Now in void loop, what we are going to do? We are going to check the condition for power on LED first. Then accordingly, we are going to make the LED to on. So for that, let me do some modification in my program. Come back here. See, if my result value is equal to this power on number, okay, so this is the value I need. Let me copy this one. Let me copy the equivalent value of my power on value. This is my power on value. Let me make a copy of this. If my power on switch is in on condition, okay, this is my power on switch is in on condition. I need to make which one to on? This power LED to on. Power LED to on. That's all. Okay, my power LED to on. Else what I need to do? If I press the same button once again, I need to make the LED to off. So for that, let me use the toggle value. So here I used the variable name called toggle power LED. By default, it is 1. By default, it is 1. Need to make this to invert. So toggle LED is equal to toggle LED. I need to do the not action, isn't it? So not action, then LED. That's all. We will check this alone first. Then we will start include the remaining things one by one. So far, do you have any doubt? Please type it in chat box. Please type it in chat box. Ram sir, shall I continue, sir? Is there any queries in the chat box?
Sir, disconnect ஆயிட்டு வந்திருக்கிறேன் இப்போ.
Okay, sir. Can I யாருக்காவது queries இருக்கு so far na interrupt பண்ணுங்க, else I will continue. Hello?
Sir, யார் இது வரைக்கும் டவுட்
கேட்கல. Okay, sir. So first we are going to check only the power on LED once. So power on LED, I am going to make it to on. Then toggle action, I am going to check it. After that, I am going to make my LED to on, buzzer to on. That's all. If we made those two, task will get finished. So let me check the braces, whether we have closed it perfectly. 1. It's okay. For if condition, this is for void loop. Let me start simulate this. See, don't bother about the IR remote and all. In IR remote also, we are going to use only if and else if statement, as like our previous exercise. If you are having two buttons, how you will write the logic? See, again, this IR button is equal to your push button. Hello? Hello? Yes. Now we will check this power on button alone. I am going to press the power on button first. So power on LED turned on. Let me press once again. It's off. So first logic is okay. So step by step only we are going. The first one, I made the power on LED to on. The next time, I'm going to make the same LED to off. What is our exact logic? Whenever I press the power on LED, power on button, master key has to be set. After that, followed by if I press the button number 1. So this button number 1 corresponds to LED control. So if I press once, LED has to turn on. If I press again the same button 1, it will make my LED to off. Similarly, if I press button 4, it has to control my buzzer. Now we will make the LED control. Then we will come to the buzzer control. Okay. For that, we need to do some modifications in our program. Go back. So this is our, see, this is our actual program. Here what we are going to do. Here I am going to read the status of the second button. Okay. So the second button I am going to read. Accordingly, I am going to control this LED. This is my next task. For that, let me include one more toggle value. So toggle values must, whenever you use the single button to operate. Okay. So here I am going to give the toggle value as simply LED. Simply LED means my red color LED. Okay. Power LED means that green color power on LED. Then for buzzer. Let me declare it for buzzer also. That's all. This is for LED output. Now we are going to make our LED to on. Can anyone help me how to write it? How to write the code? What is the program flow? Can anyone tell? First, I need to check the if condition of this one. If this condition is true, I need to make the power on LED to on. No issue in that. Okay. Followed by, I need to take the another action. Followed by, I need to take the another action. What is the action? I need to check for the second key to press. But here I have one small issue. Please see. Okay, we will do one thing. We will write then the same fashion the program. Then we will check for the output. Then you will tell me what are the modification I need to do it in the particular program. As for our C program structure, first one, I am going to check the receiver status. Once it is received, I am going to check the power on key first. Once the power on key is pressed, if it is logical true, I need to read the second button. But here we are using push buttons. Here we are using push buttons. Once I press the push button, if I release the finger from the button, what will be the logical value of this one? Whether it will be continuously true, or once I release the finger, it will become false. Can anyone type it in chat box? Hello? See, Kavyasri, if I use and function, simultaneously I need to press both the buttons. Isn't it? Hello? Can understand this issue? See here, the buttons, individual buttons only we are going to hold. So if I press the red button, if I release the finger, the moment I release the finger, this statement will become false. So how I can rectify this? For that purpose, we are going to do one thing that is called latch function. What I'm going to do is I'm going to do some latch action. Whenever I press this power on button, I am going to latch this state as long as I press the second time. How I can achieve this? Let me type it. You observe the program. Okay. Then I will tell you the real logic, how it works. Okay. I am going to use one latch function. For this? To hold my loop to work in the particular statement. So for that, I am going to include another variable name called onLatch. Okay, latch. So onLatch, I'm going to declare. Okay, so onLatch. In setup, I'm going to initialize the value, because if I initialize in the global declaration, every time it will take the same value. I can't make the logical change when my particular scenario. For that, what I'm going to do, I'm going to include it in the void setup. In void setup, initially I'm going to make it into 0. Then come back here. In this program, I'm going to use, see, as Kavyasri said, I'm going to use same and action and action with the variable name called, where it is, where it is here. Here in power on button, I am going to and with the variable name called on latch. Okay, if my on latch value equal to 0 means what? Previously I made the button to off. Okay, so if by default my on latch is 0 means my system is in off condition. That means first time I am going to press the button. At that condition, it is going to take it as a on command. Second time, it is going to take it as a off command. Okay, so here I am going to check this and I am going to make my LED to on. Okay, LED to on, and the toggle value, now I am going to keep it in the some other statement that I will show you. Okay, now I am going to, once I enter to this, I will make this on latch to toggle. Okay, now what I'm going to do, I'm going to change the on latch value into 1. That means to make my system for second press. Okay, let me finish this one, then you will observe the overall flow. Okay, so first what I did, I made my on power on push button to latch for some time. Unless otherwise I press second time, it will be keep on holding the same latch condition. So with the help of same on latch, now I am going to write the remaining statements. Remaining are very simple. All are else if conditions. Okay, else if condition, I am going to include my button number 1. What is the equivalent decimal value of button number 1? Let me check it from here. What is the equivalent decimal number? So this is my equivalent decimal number of my button 1. So button 1 I am going to copy. Okay, so button 1 is for LED. So let me take this value. If my results, else if my results value equal to button number 1 and as well as on latch is equal to 1. When my on latch will become 1, whenever I press the button first time, it will make my on latch to 1. If I enter into the loop, it will make my on latch to 1. That's all. In this state, we are going to make our LED to on. Okay, so LED to on. Digital write off. What is the toggle value we given? Toggle value by default, we gave it as 1. So let me take the same value and include digital write function. So digital write off. Yes, digital write off simple LED. What is the output pin name? It's simple LED. Okay, simple LED. The pin number is simple LED, comma toggle LED. Okay, second time if I press, I need to toggle the LED condition. For that, I am going to use the another statement. I am going to use the another statement. Toggle LED equal to not of toggle LED. Please go through the program once. What are the things we made it here? The first one, as usual, we are going to decode it. Then what we are going to? We are going to check the power on condition. Power on condition means I need to check the previous state. If my button is previously off and I press the button first time, it will make my power on LED to on, and it will produce one variable name called latch, on latch. This on latch which will help to read the second key. Okay, in the second key, you are going to check the corresponding button. Here the button number is 1. If I press this one button number 1 and also it is in on latch 1, I will make my LED to on. If I press this one button second time, it will toggle my output. Okay, let me check this output alone. Then we will include the buzzer portion. Okay, let me start simulate this. Here, power off condition we didn't include it. Okay, power off condition. If you want to include the power off condition, what is the logic I have to return? Can anyone tell? See, this is power on condition. If I press the off button once again, what is the logical change has to happen? Can anyone tell? If I press the power on button second time, what is the logical change I need to achieve? Can anyone type it in chat box? If I press the power on button second time, what is the logical change I need to do? I need to make both the LED to off. Okay, so let me write that condition also along with this. If I press my power on switch once again, so once again means this is the change. This time my on latch will be in 1. That means already my remote is in on condition. I'm going to press the same button again. If I press the same button again, can anyone tell what I need to do? I need to make this power on LED to logic 0. Simply logic 0. Here also let me keep it as logic 1. Simple. Here my power on LED is on. Here my power on LED is off. At the same time, this LED also need to be off. I need to add this also here. Here. What I need to do? The LED also I need to make it as logic 0. So all the output devices will get turned off. Immediately I need to make this on latch to 0. That's all. That's all. Finished. Okay. So if you please go through this. This is for on condition. This is for power on condition. This is for LED on condition. This is for power off condition. In power off, both the power on LED and normal LED, I'm going to make it off. Okay. At the same time, I'm going to change the latch value into 0. Now let me check the output. For that, I'm going to start the simulation. We're going to start the simulation. Close the code window. And first you make the power on button to on. Yes, power on button is on, no issue. Now you come to the LED on off button. You come to LED on off button. LED turned on. Okay. What else I need to check? I need to check the same LED button, whether it does a toggle action. Let me press once again. Yes, it's off. It's off. Okay. Now LED is off. Let me make the next time to on. It's on. Let me make the button to off. Yes. Is it okay? Is it okay? So the power on button, LED on off we achieved. What else we need to add? Only for buzzer. Stop the simulation. Go to code window. Go to code window. What are the things I need to add? I need to add one more condition for buzzer. I need to add one more condition for buzzer. So for buzzer, let me copy the value as this toggle buzzer. Toggle buzzer. So wherever I have the LED variable, where I need to paste it my buzzer variable. Okay. Buzzer. That's all. Toggle buzzer, toggle buzzer, toggle buzzer. The pin number name is no longer LED. Now it is buzzer. That's all. Then here also, once I make the master button to press, what what I need to do? I need to make the buzzer to off. So let me include that line also. That's all. Now you start your simulation. Close the code window. Come here. Make the master key to on. It's on. Check the LED. It's on. Make the LED to off. Yes, it's off. Now you check the for buzzer. Pin number 4. Okay, wait. Pin number 4 code we may not taken. Wait a minute. This logic we need to take. Pin number 4. The corresponding code we need to include. Come to the code portion. See, pin number 4 alone not works. No, we will check why it not works. Here we are using same one, but so let me change it as. Okay. Now power buzzer condition. Latch is 1. Latch is 1. Digital write off buzzer comma toggle buzzer. Toggle buzzer. Whether we have included toggle buzzer variable. Let me check once. Yes, toggle buzzer we have included. Now we will check the output. Start simulate. Close the code window. Close the code window. That's all. With this, our exercise is over. If you have any doubt, type it in chat box. Power on LED is on. Make the LED to on. On. Press it once again. It's off. Check the buzzer. Yes, buzzer is on. Again, press the buzzer. Same for fourth button. It is off. Now, the on-off control, power on control is okay. Individual control is okay. But see, we couldn't check one more logic, that is master off. Now buzzer is in on condition. Now I am going to press the power off button. I am unable to turn off this. Why? I will give you the solution. See, this is the reason. See, this is the reason, because here we are going to latch the value. At that time, once this is in latch 1, I need to reset this in the buffer. It will keep on, it will store the reset value unless otherwise if you press the another button. Okay, so for that reason, what I need to do means in this latch function alone, once I enter into the latch function, I need to reset this KCE results value equal to 0. Okay. See, once I see, since we are using the latch function, it will keep on remains in the particular this loop. After that, it will check the second buttons and it keeps on goes. If we press the off button, means the reset value won't get reset. It will take the old buffer value. For that purpose, here once I entered this list latch function, I'm going to reset it by 0. Then it will take the new value. Now you check this. Now you check the output. Go to code window, minimize the code window. Minimize the code window. Power on. Yes, power on. Both the device on. Both the device on. Now you press power button. Everything will get turned off. Since we are using the latch function, inside the loop, you need to reset the value. Okay. If you are not using latch function, means automatically it will get reset. So since we are using the latch, whenever you enter into the particular loop, you need to reset the buffer value. Else it will take the previous value and it will work for only the previous value. Okay. That's all. So with this, today's exercise is over. Now I am pressing the master power off. It's off. Take down the today's task. Take down the today's task. Please take down the task. Sir, it is visible, sir. Ram, sir. Sir, please take down the today's task. Design and implement a speed control of DC motor using IR remote. Design and implement a speed control of DC motor using IR remote. You may aware how to interface the DC motor. You need to use the driver IC. How to achieve the speed control? Please refer the day 13 tutorial class. You will come to know how to control the DC motor direction. Here, the how I am going to use the remote. As the last task, this is the master key. This master key is for to make your motor to on and off. These two volume buttons, please observe here you are having volume button. The volume increase button, you program it as a speed increase button. Similarly, volume decrease button, you keep it as a speed decrease button. Okay, please make note of the task. Whoever take down the question can leave the class. We will post the question in the classroom as well as the WhatsApp group. If you so far if you have any doubt this today's task, please type it in chat box.
கஜேந்திரன் சார் ரெக்கார்ட் கட் பண்ணுங்க.
Yes, sir.